class. Today we're going to go over a membranes example. In this example, we're given a feed composition of zero point 0.5, a feed flow rate of 2 times 10 to the minus 3 centimeters cubed at standard temperature and pressure per second. We're given a feed pressure of 40 centimeters of mercury and a permeate pressure of 10 centimeters of mercury. The thickness of our membrane is 1.5 times 10 to the minus 3 centimeters. Our permeability is 40 times 10 to the minus 10 with the units as given here. And our separation factor is 10. Finally, we're given a reject composition X naught of 0.3. And we're asked to find the cut or the fraction permeated theta, our permeate composition YP, and the area of our membrane needed for this separation. This is similar to one of the problems from the homework, but instead of being given the cut, we're being given the reject composition and solving for the cut. So for our analysis, we can write out the complete mixing model equation that we've learned in class. So this is yp over 1 minus yp is equal to alpha star pH x naught minus PL yp over pH 1 minus x naught minus PL 1 minus yp. When we multiply through by this denominator, this becomes a quadratic, which has the form of yp is going to be equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. And we're given, for each of these variables, that a is equal to 1 minus alpha star, b is equal to the ratio of our pressures times 1 minus x naught minus 1 plus alpha star pH over PL x naught plus alpha star, and C is equal to minus alpha star pH over PL x naught. And this holds for any problem where we are given our reject composition x naught. If we're given the cut and asked to find the reject composition, there's a different form of this that uses that theta variable. So we can go ahead and plug in all of our values. We get A is equal to 1 minus 10, which is minus 9. B is equal to 40 minus 10, 1 minus 0.3, minus 1, plus 10, 40 over 10, x naught 0.3, plus 10. This gives us a value of 23.8. Finally, C is equal to minus 10, 40 over 10 times 0.3, giving us a value of minus 12. We plug these into our quadratic formula, and we get that yp is equal to minus 23.8 plus or minus the square root of 23.8 squared minus 4 minus 9 minus 12 all over 2a, which is 2 times minus 9. This gives us a value of 1.32 plus or minus 0.64, giving us yp equals 1.96 or 0.678. Obviously, yp equals 1.96 doesn't make sense logically as it's greater than 1, so we can get rid of this one. And we simply have yp equals 0.678. Now that we have that, we can calculate our cut. So we remember that the formula for the cut, theta, is equal to xf minus x naught over yp minus x naught. This will be given to you on the exam formula sheet. We can plug in our values here. And we had an xf of 0.3, an x naught an xf of 0.5 minus x naught is 0.3, yp is our 0.678, and minus 0.3. And this gives us a value of 0.529. This theta comes from our mass balances. It comes from, we have LF XF is equal to L naught X naught plus VP YP. This is the mass balance on our component. We have that theta is defined to be the permeate over the feed. This gives us that VP is equal to theta LF. We also have the mass balance on our overall mass balance. That is LF equals L naught plus VP, giving us that L naught is equal to LF minus VP equals LF minus theta LF. We can plug all of this in to get that LF XF is equal to X naught LF minus theta LF plus theta LF YP. We see we have a constant factor of theta, or of LF on everything, and so we can cancel that out and get XF equals 1 minus theta X naught plus theta YP. And then simply solving for theta gives us that theta is equal to XF minus X naught over YP minus X naught. That gives us this formula for theta. Finally, the last thing that we're asked for is the area. And so we have that our area of the membrane is equal to theta LFYP over P prime A over thickness times PH X naught minus PL YP. We can go ahead and plug in all of our numbers into this. This is just plug and chug from here, aside from remembering your units. So we have 529 for our theta value. Our LF is our feed inlet rate, so this is 5 times 10 to the minus 3. cm3 at STP over second, and a YP of 0.68 divided by our permeability, which is 40 times 10 to the minus 10. This whole mess of units here, cm3 at STP times centimeters over seconds, centimeters squared, centimeters of mercury. We need to divide this by our thickness. This is 1.5 times 10 to the minus 3 centimeters. And then we have this pressure term here. So this is 40 centimeters of mercury times 0.3 minus 10 times 0.7 or 678. Looking at all of our units here, our units will cancel out. The cm3 cancels out. The centimeters and thickness cancels out. Our seconds cancel out. And our centimeters of mercury cancel out. So all that we're left with is this is centimeters squared, which is an area, and that's what we would expect. And evaluating this, we get an area of 51.53 square centimeters. So for this problem, the main things to remember are which approach you need to take based off of what you're given. If you're given your cut versus given your reject composition, you'll have two different forms of this quadratic. When you get your solution to your quadratic, make sure you take the one that makes logical sense. If you have one that's over 1 or one that's less than 0, make sure that you take the other one that gives you a reasonable composition. And from that, it's just a matter of plugging in values, and for your area, making sure that all of your units line up well.